Previously, we've talked about the electric potential difference, or voltage, right? Today, we're going to talk about two new concepts here. We're going to talk about the electric current, the resistance, and we're going to talk about the relationship between the three of them, Ohm's Law. And our target is to be able to describe the voltage, current, and resistance in a circuit using Ohm's Law. So let's go ahead and talk about those things. In an electric circuit, charges flow around the circuit, right? They move along the wires from, wherever they start, back around the circuit, back to wherever they started, right? Those charges, they're not provided by the battery. They're just moved by the battery. They're already there in the circuit. They make up the atoms and the wires and whatever else is part of the circuit. They're already there. The battery just moves them around. Now, how fast those charges move around the circuit is what we call electric current. Right? Electric current, we use a variable I for electric current. Capital I is electric current. And it's measured in a unit called the ampere. Oftentimes people say amps for short, and it's abbreviated with a capital A for amperes, right? Charge you can find, or the electric current you can find by taking how much charge passes a certain point in the circuit over the given amount of time that it takes to pass there, right? So you can find electric current by taking charge divided by time, right? So an ampere would be equal to a coulomb per second, right? So that's electric current. Electric resistance is kind of what it sounds like, right? It's resistance to the flow of current. So those charges are moving through there. I like to think about electricity as though it's water flowing through a pipe, okay? The voltage is kind of like the water pressure, right? It's like how much push is pushing the water through the pipe. The current is kind of like the current in the pipe. It's like how fast is the water moving, right? And then the resistance is kind of like how restricted is the pipe, right? Do you have a pipe that's like this, or do you have a pipe that's like this, right? So resistance is kind of resistance to the flow, right? And resistance is provided by pretty much any kind of components that you put into a circuit. Wires themselves have some little bit of resistance. The wires that we're going to talk about and use, it's negligibly small. But when you start talking about like transmitting electricity over long distances, like power lines, they have a significant amount of resistance, right? We're not going to go into that. We're just going to keep talking about our little classroom circuits. So our wires, the resistance is negligible. But really any other component that we put into a circuit has resistance. It provides resistance in that circuit. Resistance, we use a capital R for resistance as the variable, and it's measured in a unit called the ohm, O-H-M, ohm. And the ohm is abbreviated with the Greek letter omega, you can see right there. Right? So now, having talked about voltage and current and resistance, we could put those together and we can talk about the relationship between them in a circuit. The relationship between the three of them is called Ohm's Law, and you can see Ohm's Law right there. Ohm's Law says that the voltage is equal to the current times the resistance, right? So V equals IR, voltage equals current times resistance. And we can use this if we know two of them to solve for the third one, We can easily go and measure in a circuit the voltage using a voltmeter, the current using an ammeter, and then calculate the resistance. Or if we happen to know the resistance of something, then we can predict what will be the current in a circuit if we know the voltage. So let's go ahead and look at an example of using Ohm's Law to solve some kind of problems. Here's the kind of problem for us to take a look at here. It says an alarm clock draws 0.50 amps of current when connected to a 120 volt circuit. Calculate its resistance. Okay, so first let's kind of list the things that we know. We know that the current, it says, is 0.50 amps. So the current, I, 0.50 amps. And it tells me that the voltage is 120 volts. So the voltage, 120 volts. It says find the resistance. Okay, so we're going to use Ohm's law to solve the problem. Remember Ohm's law, voltage equals current times resistance. Let's put these numbers in there, and then we'll solve it. So the voltage is 120. The current is 0.50. And the resistance is what we're looking for. And then clearly we just have to divide to solve the problem, right? So 120 divided by 0.50 should be 240. And then what unit do we use for our resistance? Our resistance is measured in ohms. So there we go. Fairly simple problem for us there. Okay, so there's a little bit about voltage, current, resistance, and the relationship between them, Ohm's law. So hopefully that helps us to be able to describe voltage, current, and resistance using Ohm's law. Till next time.